Hi, this is Shannon Seaver. We're looking at linear functions and their graphs, part 2 today. On the agenda, graph horizontal and vertical lines, interpret slope as a rate of change, and use the slope and y-intercept to model data. So first of all, let's talk about horizontal and vertical lines. If you have a horizontal line, you're usually given y equals b, or in this case, y equals 2. If you see y equals 2, you know that it's going to be on the y-axis, is the first place you're going to put your dot, is at 2. And then it's at every other y equal 2 on the Cartesian coordinate plane. So at 1, 2, at 3, 2, at 5, 2. So wherever y equals 2 is where that line is. For the vertical lines, we have x equals b, or in this case, x equals -4. It is wherever x equals -4 is where that line is. So here at -4, right on the x-axis, and every other place on here. So at -4, 2, -4, 4, -4, -2, this is wherever you have points where you have x equals -4. So these ones are always vertical. The y ones are always horizontal in terms of what the line looks like. So now I want you to take a moment to graph both these lines, pause the video, and come back and check your work. So on the left one, we have x equals 5. When you have an x equals something, that's going to be a vertical line, and it's at 5. So if I put a 5 on the x-axis and draw straight up and down, that is my vertical line there. It is wherever x is 5. So at 5, 2, at 5, 4, and so on. Y equals -3 is a horizontal line, and it starts at the y-intercept of -3. So if I put a point at -3, and then I'm going to make a horizontal line going through -3. Here we have an application problem. The figure to the right shows the line graphs for the number of U.S. men and women living alone from 1990 through 2003. Find the slope of the line segment for the women. So I'm going to look at the top one. So we have 2 points here. We have 1990 and 14.0. And then we also have 2003 and 16.9. And I want to find the slope of this particular line segment. Because I have 2 points, I can do y2 minus y1 over x2 minus x1 for my slope. So my 2 y values are the following. I can say this is x1, y1. This is my x2, y2. So it'll be 16.9 minus 14 over 2003 minus 1990. So I have 2.9 over 13. If I were to divide that out, 2.9 divided by 13 is 0.223. So basically we're looking at, remember, millions. Okay? So 0.223 millions of people. If I were to multiply that by 1,000,000, I'm going to have 223,000 people per year, a change of 223,000 people per year of women living alone. So each year, 223,000 more women live alone. So now I want you to do the same thing for the men. Check to see what's the slope, and then interpret that, and then come back and check your answer. So on this one, you should have gotten a slope of 3.5 over 13, which, if I rounded it up, is 0.269. And if you multiply that by millions, you're going to end up with 269,000 men, who are the increase of 269,000 men per year that are living alone. So now let's look at another application problem. Here we find that the function in the form mx plus b, remember m is slope and b is intercept, models car sales. in millions X years after 1990. So what we want to do is look at the car sales. We have 2 points here. And first of all, we need to find the slope of those 2 points so we can find our M. We already know that B is the y-intercept, and that's right here. So our B is that number 9. So all we really need to do is find the slope. So it's going to be 7.2 minus 9 over 13 minus 0. If we put that into our calculator, we have 7.2 minus 9 is negative 1.8 over 13. And then if I were to actually divide this out, it will be a negative 0.138 if we round it up a little bit. So if I were to write this in the C of x form, it's going to be C of x equals negative 0.138 x plus our B, which we already found out is the y-intercept here, the y value of that coordinate, plus 9. So that is our equation for that one. Now I want you to find out what the function is for SUVs. Take a moment, pause the video, and come back. Okay, so the slope that I got was 2.9 over 13, which after calculating it is 0.223, so that is my slope. And my intercept was 1, the y value here, so I put 1 for that. So S of x equals 0.223x plus 1.